Hein? are coming. Wait, say you.
Mike.
Hi, Shauna.
Oh, sorry, my microphone wasn't working, so I was doing a test run. I
Okay.
didn't know that everyone could hear the test run.
All right.
All right, cool.
Good afternoon, everyone. How are you today? Hello. Is it me you're looking for? Good afternoon,
Good afternoon, sir.
Monica.
Sir Sean?
You man, you hearing me?
Yes, I'm hearing you now.
Right. Any how were you able to get any work done up between Tuesday's class and now?
I tried the tutorial, sir, and I tried one of the practice run, and I feel like it's Spanglish, but I'm trying, sir.
How was the recording?
Dear Jesus.
Did you get a chance to listen to it?
Not yet, sir, but before this exam, you said Saturday is when it's open, right? I
Mhm.
am definitely going on there and practicing it, sir. It's just during the
Mhm.
week, everything piled up, and that's the problem.
Cool. What about the others? Nobody else? No, I'm nothing to say.
Sir, I have not gotten the chance to look at it yet. I was preparing for a mid-semester
Mhm.
graded coursework, but I'll get onto it from now until next week.
All right, bless you. All right, so I gave you something new, some integration, and I went through one question with you. Didn't send you the notes on this because I didn't want any overload with information. However, at the end of tonight's class, I will send you a section of what it is that we are looking at. But while I wait on the others, I'm going to give you a question. I'm just trying to bring up this document. I'm going to write a question similar to what it is that I would have given you on Tuesday. I was about to say Friday, but Tuesday. And see how well you work at it. Remember, for me at this point in time, it's neither here nor there if you get it right, because we're just moving to the question or the topic. So it's neither here nor there. Are you seeing my screen?
It's coming up, sir. It's coming up, sir.
So it's neither here nor there if you.
Yes, I see it, sir.
Great, thanks. Neither here nor there if you get the question right. Let me reduce this somewhat. Right, this is neither here nor there if you get the question right. What for me is important is the attempt of the question. Copy. I'm going to put this question in a different color, and I'm going to project. I'm going to keep. Come on. I'm going to keep the question projected so that I'm going to keep the question projected so that what? So that you can see what is happening with what it is that we did on Tuesday, and I want you to give an attempt of this one for me. Let me put this in another color. I'll put it in, this says magenta. All right, so you have a question there for me. 4x to the 5th plus 7x cubed minus 6x squared plus x minus 9 d of x. I want you to look through. I want you to try and find the rules are very similar here. So just look at what it is that I would have done for question number 2 and try and replicate it for this question in magenta and pink. We call it pink, let me say magenta. And I'm going to give you 5 minutes to do that. By then, the other students will join the class. All right, so start working, please.
Okay.
So this is a new topic?
We started this on Tuesday.
Or this is stationary point?
No, ma'am, we finished stationary point. We did this the last piece. Oh, you did. Oh, you dropped asleep on me Tuesday night. Yeah, your secret burst. Your secret burst. Yeah, man. Feely, your secret burst. This is what we did for the last 9 to 10 on Tuesday.
Okay. What's the topic, sir?
Integration.
Okay.
All right, so start this for me, please. I'll give you 5 minutes and then I'll come back to you. Start.
Good afternoon, everyone.
Good afternoon, you 1-1. Tajay, can you link me via WhatsApp right now, please? Tajay, you hear me?
Yes, sir.
Come on, link me now on WhatsApp, please. Can you do that? Okay.
Wow, go on, business calculus. Session.
We still come, Emilio, we still come.
All right. Yes, Daddy.
Satania, can you link me now on WhatsApp, please?
Sorry, yes, sir.
No, I was asking Satania to call me now on WhatsApp. Okay, Tamoya, Tamoya, I want you to call me also. Call me now on WhatsApp, please. No.
Okay.
So Tanya, can you unmute for me, please? So Tanya, Miss McCain, can you unmute for me, please? Joan? Miss T? Joan?
Yes, sir.
All right, do me a favor. Call me now on WhatsApp, please.
Okay. So not really. All right. I'll follow.
Mhm.
Mhm.
All right. How we stay with this stuff? All right. That's soon talk back to you. All right, guys. So Tanya, I need to speak with you urgently. I've been asking you for the longest while to unmute. Let's see now. All right. So
Shauna Kate, the year now, I think may I be proactive from now, yeah? I think
all
I
right.
kind of have an idea, so I'm here.
Okay, so
But I'm outside of WhatsApp, yeah?
you're not no, well, I don't think you want us to have a conversation with everybody here, but I will. So you're not on WhatsApp at all?
Not at all.
Not at all. All
But
right,
if I can call you,
you can call me straight in your credit.
yes, sir. What's the number?
330-7311.
That's 330-7311.
Yeah, call me now before I start.
I'll call in here right now, sir.
Cool. All right, so let us see if we can get this ball going. It's important for me to do what it is that I'm also doing. There are a few others that I will need to have a private conversation with. Let me just share a challenge that I have. So when I look into the WhatsApp group, let me just go there before I. Ouch. When I look into the WhatsApp group, where are you, WhatsApp? When I look into the WhatsApp group, I can recognize Emilio. I can recognize Marie. I can recognize Ricky. I can recognize Ophelia. So I can recognize Yana because I know who Yana is. I can recognize Janar because I know who Janar is in class. But there are a few of you with
Sorry, you can recognize me?
I'm seeing Joan. I could. I'm just checking to see the messages that are inside here. The point I'm making though is like a number here, 365-2560, just has an
story
accent.
short, put your name beside your number.
Very good. So I'm only seeing an accent. So
Sir, the
yes,
one
please.
3652560, that's mine.
Okay, so you cannot put something beside the name, so at least when I see the stuff coming, I know who it is that is really having the conversation with me, because you know, we don't have a, what do you call it, one of them expensive phone there. So yeah, one of them something they're good. So you know, I don't have all my students' information attached to the stuff. There are one or two numbers that have been saved to the phone, and for the mere fact that I've taught the student over a period of time, whatever the situation is, right? But it's not preferential treatment, but I really can't add all the students in my class because trust me, I teach over 100 students per semester. So I'm going to ask that to put a name there. So at least like Mohammed, you know, who is Mohammed? You know, I could do well with knowing, you know, who is us, and you know, etc. So you do that, and then I'll be good, because what could happen now? There are individual students that I will need to. I mean, and I'll speak to the class as a whole, but there are some students in the class that I will need to have a little one-on-one talk with. So when I look at this stuff, I can know that this is this person. I don't have to scroll up and say, oh, the person, they tell me their name from up top. Anyhow, so that is personal, because I know some people don't want to remain anonymous. But for the purpose of me having this sort of communication with you in the class, it proves itself to be very useful. With that said, I know we've started a new topic, and as I said before, I am not concerned with you getting the question right. What I'm concerned with now is just how it is that you're applying yourself based on what it is that you're seeing right here. So let's go. So we have 4x to the 5th plus 7x cubed minus 6x squared plus x minus 8 d of x. And you're asked to do some integration for me. You will see, let me just hasten to see. You see me have it 1, 2, 3, 4 lines before we reach a 5th line. Hopefully by the end of tonight's class, we can move from line 1 straight to line 5. I am only doing these lines so it is that you can see how the rules apply. I'm only doing these lines just to show you how the rules apply. But in future, before the class ends tonight, what I expect of you is we can move from this line straight to the line down here, so which is our answer line. All right, that's where we're going. But I'm going to build. We're going to be building. All right, so I want you to work with me. Somebody tell me, what would be the first thing following this example? What would be the first thing that we're required to do right
Sir,
here?
Sir, so far I see the connection that you're talking about.
Ronnie,
Here
let me
we
hear
have
it.
the 3x to the third power.
Mhm.
3 times 3. 3 isn't. Oh, let's see. Yeah, I said, then make this thing. Sorry, I just saw it a while ago.
It's 3 3 3 3. So
So 3 times 3 is 9. 9x
well, and there's differentiated, you know.
No, man, I know so.
I
is supposed to be.
differentiated,
Oh dear
I
Jesus.
differentiated, you know. I'm
And that, me
This
just
one is.
say-
Oh God.
All right, so
Sir,
you-
is it
you
this
put
one
it-
that
put
you
the DX.
first?
All
So
right.
5, so it's 4x to the 5th power,
Four-
dx plus,
Uh-huh.
and then that's something the name. When name, sir?
The curly, the S.
Integration sign. That's
Yes,
the integration
Integration,
sign.
right.
Right.
Yeah, then
okay.
you're gonna have 7x cube
DX
dx
Don't read it.
plus
We give
a
you that
plus
one.
or minus.
plus integration integration minus 6x squared dx integration.
All right. You
So,
want to
so
fill
Bogle,
it up? All right.
only what the sign Bogle. You're right, you know, Bogle, but you just
There
leave out
is
the
a
sign.
minus 6x
No, no.
squared,
Okay, minus 6x squared dx. Okay, let me hear now.
then integration x
See?
dx.
That's why I say a while ago you leave out the sign because it should say plus.
Oh, plus
So that's what I
Oh.
was talking about. Say plus, then the integration sign x.
x dx.
And then
Integration sign.
minus.
Sir.
Integration sign, then minus dx. 9 dx.
No, minus first.
All right, so you can have the minus first, or if you want to put the minus inside first, Bogle, you can put the plus on the outside because you have to have an operation separating the
plus.
right. So you can put the plus and then the integration sign and then the minus 9 dx. All right, sorry. Before you come in, Emilia, somebody was saying, sir, who was that?
I saw it.
Uh-huh.
I'm finally see it. It's not about taking it, it's about putting it in. So where you have the 5 to the 5th power, that will become 6, the 6th power. And below it, you would have, check out the denominator, so you call the one below, that would be
Mhm.
5 below it. So it would be 4x to the 6th power, and 6 would be below that at the bottom of it. Plus,
Very good. Okay.
so each of
No,
them
no,
going up.
right. So don't do the rest of it just yet. But your first term is sorry, 4x to the 6th power over 6. Very good.
Uh-huh.
So this is what I want to build with you guys. I just want to take it step at a time
Yes, sir.
so that by the end of the classroom we can roll it up. Just like I give you a differentiation, I say, what is the differential of this? And
We're
you
able to
can
look
tell
at
me,
it.
yeah, man.
I'm able to see all of it, sir. Just remember to put in the plus C at the end.
Very good. So
All right.
remember now, so here what I want you to remember most of all. You're adding 1 to the power, dividing by the new power. You're
Right.
adding 1 to the power,
Power
dividing by the
the power.
new power. Yeah, man.
That's
this
it,
is
sir.
what
The new
Tashana
power.
got. The
Uh-huh.
new power. That's how Tashana got 4x raised to the 6th power divided by 6. All right. But we're going to press. Yes, Marie. I'm coming to you, Marie. But we're going to press pause on the solution because I just want you to get a feel of the rules first. Because you know when we get a feel of the rules first and then we start doing this stuff, things just come to us, right? So go ahead, Marie.
All right, sir. So when we reach to the x, like what a single x right there, oh, I'm going to do that part. But what I did, I put the x divided by the x.
No, but x is raised to which power, Marie? Nobody tell her, please. Nobody answer. Marie, that x is x. Is that x being raised to power, Marie?
X of an invisible something, sir.
Mhm.
All right, that's
Yeah.
it.
The first
Don't nobody helps her. Marie.
one, sir.
Very good, Marie. So remember, Sir just a while ago, Marie, that you're adding 1 to the power and divide by the new power. So what that answer will be, Marie?
All right, so you're adding 1 to the power.
Mm-hmm.
It's going to be x squared up here, so
Mm-hmm.
divide by 2.
Very good, sweetheart. I'm proud of you, sir, Marie. Oh, Lord of mercy, you wouldn't understand. If you're a name, I'd hug you and kiss you. I don't care if Corona is about. But I just hug you. Very nice. I really want the rest of you to get to that stage. Emilio, you're saying something, Papa.
No, I was giving the answer about Shana K. Geet and Tashana Geet. So yeah.
All right, great. No, so I'm proud of you guys. What I'm gonna do is I'm gonna copy my question. So what I'm doing here, I am updating this document as I go along. So this is going to be my question for now. And so I want you to forgive me. I'm going to do this question like I did for question number 2. Best believe, copy. Question 4, you see question 4, my other answer in 3 lines. And
Yes,
it's
sir, I see it.
good. So this question 3 is the last time you're going to see me write them only for something here.
Oh, Jesus.
Yeah, man. Yeah, man. Real talk. At the last time against me, write them only for something here, because where sir want to get you is looking at the question. Look at question 4. Look on question. Well, question 5 is a different thing that I was explaining. Look at question 2 for this section. 3 lines. And the only reason it's 3 lines because we divide this 2 into this 8 to give it a 4. Right? So that's where I want to get to. This is a different one, so I went long. Right? So I want you to just pay attention. So please do. If you
Undivided
are,
attention, sir.
yeah, man. If you are distracted somewhat, I'm going to ask you to just ask your distractions to step aside. If you're at work, tell the supervisor, give me a break. Don't do it here, because next thing you're going to lose a little work, and teacher can't pay you.
Me say, sir, me just say, when I say give a supervisor, a break, say,
You might get a vehicle before curfew.
Same way, so. All right, let's go, guys.
Or
So,
else.
all right, so let us see what we can do right here. So, okay, let me see if I can do it. All right. So, yes, I am proud of what was said. So this is going to be 4x raised to the 5th power. You're not seeing because I'm actually typing, and then dx, right? And this is going to be plus, and that's going to be 7x. That is going to be 7x to the 3rd power dx plus, and that's going to be minus a 6x squared dx. Good. And this is going to be plus x dx.
X, yeah.
X dx, and
Yes,
then minus
9 dx.
9 dx. Very good. Minus 9 dx. So look at that and tell me if you agree with that line that I just typed.
Yeah, man.
All right. Now I hear. All right. So I was having a private chat with some students in the class, and hear me out. It's the ones who I can tell you where Marie is. I can tell you where Tashana is. I can tell you where Bogle is. I can tell you where Emilia is. They can tell you the things that my Ricky catch. I can tell you where Marie is, so forth and so on. Because I'm hearing conversations. Now, there are some of you, like Miss Sutanya, that I've been calling like about a million times, you know, are way too silent. I need for you to have that level of conversation with me so that I
Sir,
can
I'm
know.
there. Remember, me have keyboard issues. You have to just see with me, sir. I am here.
No, but look how long I call you. You
Then,
didn't
sir,
send
I never hear you. You know, sir, I am here. I am right here.
Okay, so on a keyboard issue alone, you have one then. All right, cool. So I needed to talk to you. I wanted you to call me so I could have a look at one-on-one chat with you. So we're going to do that after class, please. All right,
Excuse
cool.
me?
We want to chat with you.
Oh, you want me to call you, sir?
Right, but not right now though, after class.
But you have microphone issues too, sir.
That's what I was saying, George. That's what the keyboard issues, you have microphone issue also. All right, never mind, Sutanya. All right, so what I was saying to you is that so I'm having conversations with one-on-one students. I'm doing it on a one-on-one level. If I were in class, I would come over to you and stand and say to you, me, you know, understand what going on, you know, or Tashana, not understanding what is happening, so forth and so on. Give me a minute, please. Hold on.
Yes, sir.
Right. So so this is why I did study. Now, the point I'm making is I really want you guys to be a little bit more vigilant in what it is that you're doing. Some of you are a little bit too relaxed. A little bit too relaxed. All right. Now, this is what I want to have happen. This is what I want to have happen. While I do the question, I want you to see what is happening. I want you to see what is happening. And I'm doing it line by line. If when I do it, I'm not seeing the line by line, stop me. Yours is a responsibility to stop me. Sir, how did you get that? No, wait until me done the question. Then I say, sir, me don't understand. Stop me line by line. So I say this to say to you know, this first line here that is highlighted. Look at it. Look at it. Tell me where it is that you're not seeing. I'm going to give you a minute. I'm going to be silent. I'm giving you a minute.
So, sir, when there is no sign, like the plus sign where the integration, before the integration sign, then it is incorrect, no?
This one here?
The plus, right.
Yes. Because what? Okay, very good question. So what that will say now to you, Shanake, is that you're now saying that it's going to be the integral of this times the integral of that. So it has to be separated by these operations, either a plus sign or a minus sign. And this is how now I'm going to be removing the negative signs from under there. So yes, you are correct. Which is why I had stopped you when you were saying it to me, to say that, you know, so you must include the plus signs or the minus sign as a case.
Sir.
Yes, Chris.
Right, sir. Right, so we have a little cursor bit. Can you explain to me why you rearrange that?
Rearrange it?
Why is it rearranged?
Okay, so what I should have here really, let me just
All right,
yeah. So let me. I'm going to rearrange it, but let me just put this as plus here first, and I'll show you what is happening here. So I'm showing you that I'm adding. So you notice what is happening here, that I have addition signs in betwixt all of them, because really and truly what I'm integrating, you know, is -9. That's what I'm really integrating, you know. I'm integrating -9. But what I want to do is to show you the integration.
Sir.
Yes, Bogle. Sorry about that. Yes, Bogle.
Oh Lord, me go come up for Excel and find you.
Yes, JD. No, on its own like 20, no. Yes, JD.
So I realized that the number that stands alone, it doesn't have a variable. When you get to the integration part, it stands outside of the integration. Why?
All right, very good question. And I did say that I want you to ask me the question. So I have absolutely no problem with you asking me the question. See it here. Rule number 6, it says the integral of a constant times a function equals a constant times the antiderivative, or the integral of the function. So once I have a constant, which is a number that stands alone, I can flip it outside of the integration sign. I can flip it outside of the integration sign. Let's see if I can find another example here. See here. This is the example I'm looking for. Rule 1. So this is the integral of a constant dx, right? So this is like the integral of 9 dx. So what I'm doing here, I can actually flip this outside here. So I'm carrying this constant on the outside because it's a constant. So what this becomes now, if I carry this on the outside, as we have the integral of dx. See here, so? Then we're going to have the integral of dx. And the integral of dx is going to be x. And the x now times the q may carry outside, it's going to be kx. See right there, so? Kx plus c. So once you have, once you're integrating a constant, trust me, you can just take out the constant and just put it on the outside and just integrate the variable. It makes the calculation so much easier. So this is what I'm saying to you, JD, that, you know, the truth of the matter is, when we're doing the question, there is no need for us to write 5 and 6 and 7 and 8 and 9 and 10 lines. No, we don't want to do that. Crazy. What I want you to do is to look at the question and do the question in your headspace while write the question as you're doing it. Write the question as you're doing it, right? Write the answer. So you're working the question in the headspace and writing the answer simultaneously. There is no need for you to be badgering or writing down the bullet lines. No, man. Yeah, big school this, no, man. Big school. Big school. Big school. All right? Okay. Any other question? But good question though, JD. Any other question?
Yes, sir. Go back on it.
Go back. Okay. Go back down to here. Number 3. Right.
Sir.
Mm-hmm.
So where you have at the end there, where you have the plus and then the right name. That's something there. Negative 90. That's how. Sorry, you change it. Because this is how I had it first. But
oh yeah. I put the plus sign here. So Emilio asked a question. Emilio. Somebody asked a question.
Sir, is it that we don't have to do it? We don't have to have the plus sign. Just have the negative and then sorry, what is something name? Integration. And then the negative 9dx on the outside.
Yeah, you will have it still now, but I'm doing it step by step now because I want you to see my stepwise.
Oh, because you did have the negative.
I had the negative on the outside.
And the 9
right.
out there, so but
right.
I have it like this. I thought it was wrong.
No, man. What I'm trying to do is to do it stepwise, and then the next question we're going to be doing is going to be just a one shot, and you're going to see how it happens one shot.
Okay.
And then we're done. Okay, very good. All right, I'm going to entertain one other question because I just feel that there's somebody else who is not understanding. Please, I give you an opportunity to speak to me. All right, none? Shall we move?
Sir.
Yes, please.
But then again, in a class. No, they wait in the middle. Edicos have me tell if we do something fun again.
Hey, man, afterwards.
All right, sir. Cool.
Afterwards, cool. All right, now, so, okay.
Yes, sir. All right, so the system may come to class look late soon, but me analyze the line we had to like right beside the rule 7 so. Me analyze how we get the 4x5 and the dx them. So you put the separated to the dx and let's just say flip it and such it explain back to the girl there. So. And the plus them, you see I have to separate it by the plus them. If so look on 7x to the cube there, so dx. Up at top we have nothing there, so now plus over there, so what you use back a plus there, so show me up a little bit there. So some know so the plus separated. And then you put back the minus 6 square, x square.
Right.
The plus with the right there, so and then you separate the x minus 9. And then you show the dx then there. So yeah, so we really understand the line there.
All right. So what I'm doing, Stewie, is just showing you step by step what is really happening with the question. Because I really want you to get what we're really doing. So I'm showing you step by step. So it's not really, I'm not really changing anything per se. I'm just showing you how we can write the question step by step and how the laws apply. So look at this piece here now. And this will now take into consideration the question that Ophelia just asked a while ago. So what I'm doing here now, Stewie, I am separating my constant. JD just asked a question. I'm taking out my constant because we don't really need to integrate the constant. Take out the constant and then just write x to the 5th dx. Take out the constant 7, clean up front. I'm going to have the x cubed left. Take out the negative 6 now because as far as I know, the negative 6 is a constant. So I don't know if that now answers your question, Stewie. And the negative 6 comes out here and just leave the x squared there. Right, because really and truly, what my aim is to leave everything after the integration sign supposed to be in x, so to speak, because that's exactly what it is that I'm integrating with respect to. This x here, blow, sir, there's a 1 right here, so you notice it seems like we never touch this because the 1 is still right here, so that is right here. So the 1 here now, we took out the negative 9 and just leave all of that. So what I'm going to have from here now is my integration what did I do right here? Sorry, undo. Oh, right there I would have. Okay, right. So that piece comes up here, so, and it goes for that piece right here. So what I was trying to say to you is that the integral, we don't say 1 dx, we just say dx, right? So this is why we have that piece, and then now I will now move into paste. This here, where we're adding 1 to the power, divided by the new power, adding 1 to the power divided by the new power. So that really and truly becomes, down here, come on, get off. That really becomes 4 x to the 6, x to the 6 divided by 6, because I'm adding, I want you to watch this here. Where is my spotlight? That's what I want you to watch. Remember now, I am adding 1 to the power and dividing by the new power. I'm adding 1 to the power and dividing by the new power. Always, every single time, barring none. I'm adding 1 to the power divided by the new power. So this is going to be plus 7. Look at it. Plus 7. I move the cursor because I'm using it. Plus 7. Adding 1 to the power here divided by the new power. So that becomes x to the 4th divided by 4. Then I'm going to have minus 6. I'm adding 1 to the power, that is x cubed, x squared becomes x cubed over 3. And I'm adding 1 to the power, and Marie says to me, sir, there is a 1 up here, so that becomes 2, right, an imaginary 1. So that becomes x to the 2nd power now, divided by 2. You have to, all of them something we will learn, we can't forget it, you know. And that 9 now becomes negative 9x, because it picks up now an x. So it becomes negative 9x. So that's what that is. Let us go through it and see if we can. I'm gonna delete this line because that line is exactly the same as that one. All right, let us see if we can agree with this now. So this 4 is this 4. This x to the 5th power, I'm adding 1 to the power and dividing by the new power. So when I add 1 to 5, I'm going to get 6, and I'm dividing by 6. That one finish. You know, I'm going to show you something.
Sir, I see why you say we can't see the answer before we go to
absolutely, absolutely. Because the 1 year, so let us go. No, let me not do the Chana K. And just do this first. So this is going to be 7. That's 7 right here. So
Chana K is Janelle.
Sure. 20. All right. And then now we're going to have x to the 3rd. Oh, no, so not like bad man. X to the 3rd is going to be, add 1 to the power, 4 over 4. See here? X to the 4th over 4. Minus 6. X to the 2nd, it becomes x to the 3rd over 3. See here? X to the 3rd over 3. The 1 here, remember to have an imaginary 1 up here now. They're not going to put the 1 up here now. They make like if you no set of a 1. So you can have 1 plus 1 is 2. So it's x squared over 2. See right there, sir? And the 9 years old now, remember now, the 9 years old, I got pick up another 9. It'll go pick up another 9. Let me be the 9, you remember the integral of x. The integral of dx is just x. We don't say 1 dx. When we integrate, go ahead.
Sir, so when you say the integral of dx is, you say 1?
Yeah.
Yes,
but we don't write it.
Oh, so the 9 that pick up that x to the left over there, sir.
It's the one.
All
right. I'm going to show you something. I pray to God that it doesn't confuse you. I didn't do it the last time, but if I'm teaching, I don't want to not teach you the correct stuff. JD just said, what does she say? When we just talked about a while ago, when we say I can do the thing, I just want to show you something, and then if it's giving you any problems, I would apologize and then move on and then fix it. Please. All right. Lord Jesus, I was sure I'll go with him something. We can't understand the matter. Some teacher wants something, and then after that, you put in something else, and then something. Don't worry yourself, man. Or the same thing we're looking at. Let me just explain why I put in this here, because I want you to see what is happening. You see this piece right here, so? The integral of 4x to the 5th dx. This piece.
Where to go the integral sign?
Right. Hold up. You
All right,
see?
sir.
Yes,
Just an
please.
observation. So far, what I'm saying is that you're moving all the, can I call it constant? The actual numbers behind the integral sign. You're shifting them to the left.
Yeah, that's what I did. That's what I did. That's what I did. You're correct. That's what I did. But I'm trying to develop something here, and I think, you know, when I teach the correct thing and you understand what I'm going, you will understand and appreciate it better, I believe. All right, I'm just going to do one for now, and I don't have anything else but just my colors, so you can follow what is happening right here. All right, let's go. This integral here, 4x to the 5th. I will go through and color code all of them so you can see what is happening. This 4x to the 5th is me splitting it from the original question to show you that the law does work, that when you're doing something like this, it can integrate them individually. So I'm taking out this 4x to the 5th, but when I take out this 4x to the 5th, it is being integrated by dx. So watch it. If I put this parenthesis right here, so all of these in the parentheses, it means that dx here, absolutely, Emilio, that dx here go under 1 year, it 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 go under 1 year. So really and truly, we don't have one dx. We have 1, 2, 3, 4, 5. As many terms we have inside here, we have as many dx's. And that's why whenever I give you anything like that, I don't just put the dx like that, I always enclose it in parentheses. So as many terms as you have inside the parentheses, those are as many dx's that you'll have. So you have one dx so, one more, see so, this the dx right so, the dx right so, the dx right so, the dx right so, and the dx right so.
I see it, sir.
To make can't write all of the dx, but just split them in a one something and just parentheses it and just call it dx. Now watch me. When I do this here, so I mean integrate 4x to the 5th, best believe that because this is an indefinite integral, when I integrate it, I'm going to have my plus c. I'm going to jump this and come down to here. So I see it. Me write back the 4, and then I'm adding 1 to the power x to the 6 divided by the new power x to the 6 plus c. Plus c. I must have my plus c because I am integrating this down here, so right here, so don't it? Tell me, see, I see that, don't?
Yes, sir.
Is it a term here, so? We don't have the time to do all of that, no. But is it a term right here, so? The term right here, so when we integrate it, we're going to get all of this, including the plus c right here, so talk truth.
Yes, sir.
Oh, no,
Yes, sir.
Talk truth. Talk truth. See it, man. See it.
Hold on.
Finally start seeing now. I can see clearly now.
Right. You see, you know, Chris, I see it, you know, because when Chris tried to sing, you know, Chris says something. All right. You know,
sir. I don't feel that.
I see me so. See me so. All right. You know what I'm doing? I really want to make you guys see what is happening. I'm just going to do 2 for now in the interest of time so that I will fix the document before I send off to you guys. Which one is that? That's P. That's that. All right. Let me just put the plus sign to be black. See that plus sign here says black.
What confused me are the last part. We have 9x plus c plus a big T.
Yeah, man.
Big C.
Yeah, man. Don't worry about it. We are catch this so. So now, so let us do. So this black plus sign is this black plus sign. You see the integration of this orange something right here, so all of this here, so gives me all of this. Why, sir? Because remember the integral of a constant is just a constant, right? So I put right this so. The integral of a constant is a constant with another x to it. But remember, I'm taking out the constant, bam, in front of that. So that's why the constant stand right here. So then I'm going to integrate this x cubed. When I integrate this x cubed, it becomes x to the 4
over 4.
over 4 plus c.
Mm.
Because it's an indefinite integral. Sir, how you know indefinite? You keep saying indefinite. What do you mean by indefinite, sir? I don't have any upper limit and I don't have any lower limit. Some of the question them, when I move to it, you see, the one is not an indefinite integral. The one is definite because the one have a one
upper limit and a lower limit.
A lower limit, very good. So I have an upper and a lower limit. So this is not an indefinite integral, but it now becomes a definite integral. I can say that Emilia lives at number 10, Jesus Close, and that is a definite address that that Emilia live at. I can say now for an indefinite integral that Emilia lives along Heaven's Lane. No, but sir, Heaven's Lane have no avenue around this, so yeah, no houses around this.
A long street.
It's a long street. Yeah, man. So it is indefinite because I don't know exactly where. But once I can say number 10, right this upon Jesus Close, this family. You know exactly, and you can pinpoint. You can go to Jesus Close, look for number 10, and can knock and say, Emilio, there you are. All right. So this is what it is. So this gives me an exact thing. And when I get to this, I have a lovely story to tell you. A very nice story. And this story will allow you to understand what is really happening. Let us jump back up here. Let us jump back up here. Nope, that's not where. Right here. Now, so all of this in orange is all of this with a plus C. And then,
sir, before you go on, I have a question. What I noticed a while ago when you scroll down, you had a negative one at the top and a 1 at the bottom, correct? It means that 0 is in the middle where the indefinite, the integral is, right?
There's going to be a series of something that come in betwixt those.
Okay.
A series of something.
And it's actually a range. It actually gives you the
right.
range.
Yeah.
Okay, I get you now, sir.
All right. Put a stuff. Where am I? Okay. So look at what happened. You see everything in black right here, so the integral of everything in this. Oh, Jesus, I give you thanks. Does me say everything in black? But the truth is, sir, which black? Because there are many blacks. All right, so call that purple. We can call this purple. Hey, we're supposed to respect my teacher, and the teacher. When you go to school, you have them teacher, you sit down and do them something, you know. Teacher said, learn, you better learn. Teaching and teaching an argument. Teacher can't tell, teacher said, oh, teacher, hello, write it off on the board, but not sending the notes. All right, let's go. So this here now, this black one here.
Sir, sir, we appreciate it, sir. And we are working with you.
I know, not go pass it, man. So you see, when I integrate this piece here in a block is this. Oh, sir, it's true, you know, because they took out the -6, sir, right here, so. I mean, you took out the -6, so you just have x squared, and you always say, sir, that you added 1 to the power. Once you're integrating, you add 1 to the power and divide by the new power. So if this is x squared, sir, 2 plus 1 is 3, so you can have x cubed, and then you can divide by 3, same way, so. But, sir, remember, you're not finished, you know, because you're talking about an indefinite integral, and it's indefinite because you don't have an upper limit and a lower limit, so you have to have your constant of integration. Very good, and that's why I have this plus c. Similarly, this piece here that is in orange, purple, this purple piece here, I'm integrating, but sir, I'm not seeing a constant here. Okay, fine. So if you don't have a constant there, you don't have nothing to take out, even though there's an imaginary one there. So leave it alone. Just go ahead and integrate as it is. But sir, there's no power. Come on. Remember, when you're not seeing a power there, you can assume 1. Sir, why could it be 0? Had it been 0, you wouldn't have an x there. You just have the dx, because anything raised to the power 0 is.
Sir, I have a question, JD.
Go ahead.
You said that the square has a imaginary 1, right? The x has an imaginary 1, yeah, 1 square. But you're saying that in front of the x, there's an imaginary 1, but we should disregard that, right? Why should we disregard that and take into consideration the imaginary 1? We call it now.
Up top?
Yes.
Okay. So all right. I see your question. The one in front of the x, which we call the coefficient of x, is fine because we don't really need to write 1x. When we write 1x, we understand that it is just x. When we write x, we understand that it is 1x because there's 1 in front of x. If the coefficient of x is greater than 1, you must indicate by writing the coefficient there. However, the power, once I have x, once I have a, remember the rule in pre-calculus, it says a is the same thing as a to the first power. So it makes a difference when it is that you have a power. Because had this power been anything greater than 1, you'd have had to indicate it just like we have a 2, just like we have a 3, just like we have a 5. It can't be 0 because anything raised to the power 0 is 1. So this -9 really have an imaginary x to the 0 right there, so because x to the 0 is 1. But when you're not seeing a power, you can assume that there's a 1 here. You see, because 1 is such a beautiful number. We don't have to write x to the first power. We can simply write x. We don't have to write 1x. We can just simply write x. Just like how in the law, it says whenever we're integrating, we're not going to be writing 1 dx. We're not writing 1 dx. We're simply going to be writing dx because this one is understood to be there. If the number is greater than 1, best believe that we have to write it. Outside of that, leave off the 1. Leave it off. So this is why the rule says written simply as dx, we don't write 1 dx. So which is why sometimes when you're writing functions and you put, sir, the answer is going to be 2x squared plus 1x plus 3. If somebody says, but sir, I know that me get 2x plus x plus 3. Yeah, man, you're also right. We don't have to put the 1 there. And then now this is where students get confused and say, but sir, you just said that x is equal to 1. I did not say that. I said that the coefficient of x is 1. What is coefficient? Coefficient is a number in front of x. So it is a coefficient of x is 1. So once the coefficient of x is 1, I don't have to write it. Once the power of x is 1, I don't have to write it either. I don't have to write it either. I stopped here just now because I did not semester 2. I didn't. Yes, please.
You said you stopped sharing because my volume, my background is low. Sorry.
I want to show you guys something. Okay. I didn't teach you guys
the logarithm thing,
the indices thing,
and the logarithm thing, sir.
Right. So look at what I did with my students for indices and logarithms. And this is what I wanted. Lord Jesus, where part it there? Yeah, see here, number 8 and number 9. And based on the difficulties that they were having, I even give them narrative. The narrative is anything that is raised to the power 0 equals 1. Anything that is raised to the power 1 remains the same. So what I'm saying to you is that a to the first power is simple, just write it as a. So if I don't write the a to the first power, I know based on indices that what I do have is a to the first power. You get that, JD?
Yes, sir.
Sir, we can't get a document here. Send a document to them.
I can send it. You don't need the rest. I can send you the rules of the indices. This topic.
I want the entire document.
Okay, I could. Right?
Thank you very, sir.
Yeah, man. So if you look at, yeah, man, no problem. So if you look at it now, you have a to the 0. Anything raised to the power 0 is 1, right? But just remember now, a is the same thing as a to the first. And if I write a to the first, we mean a. All right? So just remember that that's exactly what it is. That's exactly what it is. All right? Okay. So let me stop share here and let me go back now to our integration. Okay. Very good question, JD. I like it because at least now it gives an opportunity for students to see what is happening. Okay. So the purple to the purple. And then this 9dx. Now let me find another color.
Sir, you're not sharing.
Oh, thank you, mommy. Let me just finish this and then go back. Share screen. Thank you. All right. No, it's 9x. It's 9x plus c. It's supposed to be blue. This plus sign supposed to be black. And then Emilia knows say, me I follow you, sir, but you want to know better the big old seed that come from. All right, cut it and get in there. All right. Now, So this negative 9x right here, dx. When I integrate it, this negative 9 is on the outside here, so I have this negative 9 right here. So, and I'm going to integrate dx. So when I integrate dx, I'm going to get x based on the same rule that I just spoke to JD about. And I get that, and I have my plus c. All right, sir. Now understand? No, sir. Can you please explain to me why you get this plus c, big C? All right. Thanks for asking. 1, 2, 3, 4, 5. One, two, three, four, five. One is green. One of them is orange. One of them is black. One of them is purple.
All right, sir.
Yes, honey.
Well, you have the 2, as in the it would be x would normally have a 1 at the top, and you add one more to it, become 2, so it becomes x squared. So because the 2 is up there, you put the 2 at the bottom again. So that's how you end up with that 2. I understand that figure. After 6x to the x cubed over 3 plus c plus you get the x squared over 2. I understand how you got that. That's what I'm saying, sir.
You understand?
Each of them each of them basically have plus c at the end.
Very good. Why? Why? Let me see if you get it.
You're all right. I don't know the reason why. I just noticed that's what I'm seeing here, sir.
Okay, fair. Press pause.
Without the C, you said without the C, it's wrong, it's incomplete.
So tell me why.
I don't know, sir.
Okay, press pause. Can somebody tell Tashana why without that plus C, why do I have a plus C, and if I don't have a plus C, it is incorrect? I use that terminology and I want her to be reminded of that terminology because we are integrating what?
The constant.
I'm integrating a what?
Integrating dx.
The constant, sir.
It's an indefinite integral.
Indefinite, sorry.
So Tashana, so once I have an indefinite integral, I must have my plus C, my constant of integration. When I have a definite integral, I don't need a plus C.
Oh, the C represents the constant, sir?
Of integration. The C represents the constants of integration. All right. So let me just put that there because it's very important. So let me just put this here.
Without the C, it wouldn't be it wouldn't be complete, sir.
Right.
It would be a different thing altogether.
So put it this way. So Emilia lives on Heaven Street. There are many houses on Heaven Street. Is a long street because I know we are going to heaven. So it's a long street. So Emilia go walk until Jesus come. Sorry, me will walk until Jesus come because I don't know which of the houses on Heaven Street that Emilia lives at. However, when I have my constant of integration, I would now need to be given some more information. And with the additional piece of information that I will be given, I can then decide where on Heaven Street I can find Emilia's house. And that's where the definite integral is going to come in because I'm giving you something more definitive. That means I can pinpoint that, oh, Emilia lives at number 10, Heaven Street, right? As opposed to be walking up and down and have no clue where he lives. But this may take it a little closer to home. So Emilia is saying, sir, why do you have this big C? No, you notice I tried to colorize it. This C right here is this C. I want you to watch me now.
The green one, sir.
Right, watch me, yeah, watch me. The C here is this one.
Yes, sir.
The one here is this one.
Yes, sir.
The 1 year and the 1 year and the 1 year and the 1 year. So them 5 C's here, when I add up them little C here, I'm going to get one big C. Sir, all you know, because a constant plus a constant plus a constant plus a constant plus a constant is just going to be a bigger constant. Talk truth.
Yes, sir.
Right. So when I gave you the question last class, you notice I did not have the individuals plus C, plus C, plus C, plus C, plus C in here.
No,
all I
just
did
mentioned that we must put the C at the end.
And all I did was put the plus C at the end.
Mm-hmm.
But in hindsight, I am saying to myself, don't show them that because let them understand that When you find it, and I'm going to amend the first piece of the question before I send up the document. So when you do the individual piece, each of these individual pieces will have a plus C, will have a plus C, will have a plus C. However, you remember I said to you that when you're doing the question, all of them will go right up, in the middle or something. I don't need to see it because this is big school. Only going to do the something, but in your headspace, you're going to know that you're going to have one little C, plus another little C, plus another little C, plus another little C. When I add up them plus a little something there, we're going to get one big something. Put it this way. It is the widow's night. It is me having $1 plus $3 plus another $5 plus another $1 plus another $1. Then give me $10. So me having my $1, my $3, my $5, my $1, and my $1 to give me my $10. So the constant here is 10, and it's because the constant is broken up into these 5 little pieces, right? So when you're doing the question, you don't have to put this little piece and this little piece in there and this little piece in there and this little piece and this little piece. You can only put this big piece because all of the little pieces then when add up to give me this one piece. So a constant plus a constant plus a constant plus a constant plus a constant is going to be equals to a constant.
Sir, I have a question. Totally related to this. I noticed where you had switched over, where the X is, you put it to the end and put the 9 in front. So if we don't switch it like that, will the answer still be correct? Sir?
This X here? I'm trying to follow what you're saying. This X here?
In the initial, the original equation where you have 4x plus
this one here with the 9?
Right, you move the X on the inside, that's on the inside to the outside, and the 9 was on the art. On the last thing down at the bottom down here, sir, where you have the 2x and you have the
This
9
one?
at the end.
Hold on, Tashi. I want to follow you. So tell me, is it this? Let me know where my spotlight is so I can follow what it is that you're saying. Is it
so
right
I
here?
see it. I see it now, sir. What I was looking at, when you scroll up a bit, please, sir, could you scroll up just one little bit, sir? Right, how you put everything, you grouped everything together. I saw the X on the inside, and because at the end you had negative 2x at the bottom where the red is the answer plus C, I thought that you had switched it, but no, it's just my eye, sir. Sorry.
Okay, all right, cool. Okay, because we know what I thought you were saying is that this X and this 9 gives me this 9x here because this is a
No,
different
that's not
term.
it. No, that's not what I was saying.
Okay.
Make me
All right,
half
cool.
blind. I had to make the screen big to see. Sorry, sir.
All right, cool. That's all right. Okay, so this line was very important for me to explain what is happening. It is just, you're the big word, Norman, like use big word in a time, get so like it right. You see all these little C's, this is just a conglomerate of the bigger C. Conglomerate means just a small, fragmented pieces. So it's a fragment of something that you just put together to get a big something.
I use the wrong word then, man.
Which word am I supposed to use?
It's a subsidiary of the bigger C.
Subsidiary of a word, conglomerate.
No, remember say the C at the head of the group, you know. The little C's are what makes up the group.
Right. So this C here is a conglomerate of these little C's. So this big C is a portion of them little something here will make up the something. So at them little something here make up that something here, you get a big C here. So this something here is now, it's formed as a conglomerate, meaning it's a fragment of something else. Subsidiary could be another word that is appropriate, but that big C is a conglomerate, meaning that you have, right, so you have other little something coming. Very good. Yeah, and let me just put this in real life terms. Sometimes, think. Somebody may have like a gallstone or a kidney stone. And then the doctor say, here the plan, come, take this medication and you should pass it. But when you check a stop and the doctor look on it something again, it broke up in 10 pieces. And the 10 pieces are broke up. When the doctor get them out of the system and it come back, it show you the real size of the something, right? So it's just a fragment, a subsidiary, a conglomerate. So it's just these small little pieces. And that example is a perfect one to show you that the size of the stone that the doctor can actually measure it in your system from the x-ray that was done. So the size of the stone, the doctor can say, no, that stone is 3 millimeters in size. 3 millimeters are going to be very painful for you to pass. So you can't pass that naturally. The doctor will say, I have to fragment it, right? And when the doctor fragment it, the doctor can pray to God that it don't dissolve and it don't fragment into too many different pieces. And the doctor is able to break it up and say, okay, it's broken into 5 different pieces. And when them come out, the doctor can actually put it back and show you, say, boy, see it here? And then pieces that this was a big stuff that I was looking at into your system. All right. So this is what the integration is really talking about. This is what the all right, mute for me, please.
No.
Oh, that's okay. No. Mute for me, please. All right. So, in essence, this is what the integration is. So, if you look at it, oh no, I don't finish it. Hold on there.
Yes, sir. Because the bottom piece not correct.
Yeah, no. I truly explain all of that thing.
That is what I was saying, sir. So something look different.
No, man. Remember, say never finish the question. If just reach a line, the second to last line. So the last line. So like I'm putting the answer now, we will see what I go.
Yeah, man.
Sir, it's divided. We break it down, so it should be like 2/3, right?
Yeah. Wow, yes, so nice. Very nice. So I'm gonna put in copy. I'm gonna put in an extra line because I just wrote that to show you where. So yes, you're correct now. So I'm gonna have 2/3. So you can see what I have there. So we have 2/3, and we have the 7/4, and then this one is going to be 2x squared. I mean cubed on.
So what about the x's?
No, the x can't change. So I'm not if we cancel the x.
Oh, because I didn't hear you say it. That's all.
Oh yeah, man. The x can't change because you know I'm not going to cancel the x. So that will go turn to the. So look at that and tell me if you agree with what is happening right there now. So we have a 4x to the 6 over 6 plus a 7x to the 4/4 minus 6x cubed over 3 plus x squared over 2 minus 9x plus c. So what I'm doing here is just doing a little cancellation to, representing my answer to its lowest term. As JD says, 2/3, simplifying it right. 2/3, this will remain as 7/4.
That can't nothing.
Right.
Go
2 times.
2 times.
So I just get 2x cubed.
2 times.
See that? So this here now becomes my final answer, right? So if you look carefully here, let me just put all of this now in.
Yeah, not different. Not already. Yeah, put an I ready.
Right. To show you that this is now my final answer, right? So so the question was, sir, I see what it is that you're saying that we can move the rector from the first line all the way down to the last line, and I'm going to do it with this question. I want you to watch me, please. Give me your undivided, just for 2 more minutes, please. 2 more minutes. 4x to the 5th is going to be 4x add 1 to the power divided by the new power. 4x to the 6 over 6. See here? 4x to the 6 over 6. This one is 7x cubed. It's going to be 7x add 1 to the power to the 4th over 4. See here? 7x to the 4th over 4 minus 6x squared is going to be minus 6x cubed over 3, sir. See here? Minus 6x cubed over 3. The one are going to be, sir, this is x squared over 2. Easy 1, 2, 3, sir. See here? X squared over 2. And it's minus 9. Sir, this is just minus 9x. See here? Minus 9x. And I must have my plus c, my constants of integration. And then I break this down to get this one. So all of what I did right here, so, is just an explanation for you to understand how the thing operates and why I do it. But I don't have to put it like that. Yes, please.
When you say you break this down to get this below, what's in red below is the final answer?
It's the final answer, right? So you see that this 4/6 is the same thing as 2/3.
Yeah.
And this 6/3 is the same thing as 2.
Negative.
So I'm simplifying my answer. Yeah.
Okay, sir. I get you. Thanks.
So what I'm saying to you is I'm not going to be a question like this carries about 5 marks.
So sir, question. If we get the top question and we do all of them bag of breaking out, we're not getting a mark sheet. That is
pretty much. So you know where the 1 mark will come in, Emilio? You get 1 mark for this, 1 mark for this, 1 mark for this, 1 mark for this, and 1 mark for this. So that's why I could tell you the question carry about 5 marks because I have 5 terms. 1, 2, 3, 4, 5.
Sir.
Yes, one.
Sir. Just you're saying that the steps before doesn't matter because the one
No.
mark is just in the answer alone.
Yeah, because
I'm not saying that,
it doesn't
it
show
matters,
you,
but
show
you don't have
how
to
it
write it. You're not writing it. You're
No,
not
ma, but
writing.
right, but where the one mark come in.
That's what I'm saying.
Answer.
So these steps matter, but it's just that you're going to get 1 mark for this piece here, 1 mark for this piece, 1 mark for this piece. So remember, you know, if a 5 mark, you know, me can't give 1 mark for this and then 1 mark for this and then 1 mark for this. No, because somebody can just move it from here so and just jump to here. So once it is that you integrate this piece correctly, you get a 1 mark. Once you integrate this piece correctly, you get another 1 mark. This piece, another 1 mark. This piece, another 1 mark. This piece, another 1 mark. So if you have all these pieces alone, you're not going to get 5 out of 5. You're going to get 4 out of 5 because I'm going to take off a mark because I don't have a constant of integration. But once you have a constant of integration, you get the full 5 over 5. But these steps here matter. These steps matter because you have to go use these steps into your headspace. 1, you know, so you have to integrate individual pieces right or so. 2, you know, so you have to take out the constant and just integrate the variable. 3, you know that we add 1 to the power divided by the new power. 4, when you do that, you're going to get that. 5, you're going to fling back the 1 up here, so just like so. 6, you're going to reduce it something. So all of that you're going to do in your headspace. All of that you're going to be doing in your headspace. Every bit of that step you'll be doing in your headspace. All right? Now, this is 639. Let me show you what I'm talking about. Let me go to this question number 4. Right? It says to find the integral of 4x cubed plus 3x squared minus 1 minus x minus 1. You notice I have x to the 0 in very pale lime green. I really don't even want to see it. But I put it there because anything raised to the power 0 is 1. Sir, so why write it there? I was just showing you that, you know, this stuff is in x to the 3, then 2, then 1. That's the point I was trying to bring across, that this is the first power.
And the one that is there has no x, or x is 0 right there.
X to the 0. Right. So look at what is happening now. So I'm doing my integration. Watch me. 4x to the 4 over 4. See it right here, so? 4x to the 4 over 4. Then, sir, you know, so you write that, come here, do that in my head. You know you're adding 1 to the power. You see when we have right here, so? Come on. You see when we have right here, so? We add 1 to the power and then divide by the new power is the most important something in this calculation. Look here. 4x cubed, and we're integrating 4x cubed with respect to x. What we need to do? Add 1 to the power and then divide by the new power. Look, 4x, add 1 to the 4 divided by 4. See it right here, so. You add 1 to the power divided by the new power, 3x cubed over 3. See it right here, so. You're adding 1 to the power divided by the new power, minus x squared over 2. See it right here, so. You're adding 1 to the power divided by the new power, x to the 0 plus 1 is x to the first, minus x to the first over 1, which is just minus x. And my plus c, my constants of integration. Sir, but this can fix up a little bit. Yeah, man. So I'm just going to write one more digger line. 4 divided by 4 is 1. So I get x cubed, x to the 4th. This divided by this is 1. So I just going to get x squared. That one you have to get the fraction. Sir, that one you're done. Both back. So,
sir,
yes, please.
You can just go over back the 1 and where you put the green x to 0, just explain. So normally we would only see x minus 1, right?
Very good. You'll only see the minus 1. Very, very good, honey. You will only see the minus 1. But I put it x to the 0 just to bring across a point here that when you're adding, when you're integrating, because you have a power 0, you can add 1 to the 0 to get x to the first. And this is why this piece here that I'm highlighting now becomes x. You don't see it yet?
X over 1 is x.
The only reason is because we have the 1, right?
Very good.
So if it was 6, then it wouldn't be like, okay.
No, man, if it was 6, you'd still have it. Any constant, you will have the x raised to the power 0. If it was any other power, we'll have to write it. It is imaginary, and that's why I put it in there's something there, make it look very imaginary. Remember, this negative one is a constant, you know. Right. Minus 9. See, Tessa, look at this vocal. See that vocal? Minus 9. But when I integrate minus 9 with respect to x, I'm going to get minus 9x. See, Tessa, don't need some minus 9x. Sir, why? because there's an x to the 0 after the 9. I mean, I add 1 to 0, so I'm going to get x to the first power divided by 1. And when you divide by 1, it's just like it's just the same thing.
Oh, yeah,
Alright?
yeah.
Yeah, man. So that's how we get it like that. So what I'm saying to you is question 4 is how I expect you to do the question. Question 4 is how I expect you to do the question. All right. I'm not even going to go to the natural logarithm just yet. I want to
go to the we call it the one we raise to the powers them. Oh,
yeah,
sorry,
I just want to,
higher.
Right. I just want to give you another quick one just to see if you're really getting what it is that I'm trying to bring across tonight. I just want to see that you're catching it. All right. Let me just copy this. Let's go. Integrate for me, please. Let me just reduce that. What do I write in my first line? I'm integrating x to the 8. What do I write?
X to the 8, sir, would be x to the 9th power divided by 9.
What would be the next term?
The next term beside the one that's x to the 5th power, it will be x to the 6th power divided by 6.
What would be the next one?
It would be negative x to the 3rd power divided by 3.
And what would be the next one?
Last one, negative 5. That's it.
What would be the last one?
Oh, C.
Thank you. Everybody see that?
Yeah.
Yes, sir.
Good job. And I'm typing, so that's why I don't put the answer just there just yet.
Oh, hold on.
Ouch.
Oh, okay. Yeah, man.
Can they all see that?
Yes, Chief. Yes, Chief.
Yes, sir.
All right. Let's up. Let me tell you something. You know hard, you know.
When
me tell you say it nice like oxtail and rice and peas with the broad beans.
Sir, it's only nice when we do it now.
So we understand it's very nice.
No man, it's nice, man. I don't like to man. The bone for the oxtail soft, so you can try it up. And if your stomach good, you can swallow the bone. But it's nice, man. It's really very nice.
Sir, let's just do one of the challenging one, because
Shona K, leave me alone. Because there's nothing challenging about this.
These one won't be on the exam, yeah?
Of course, Shona K. You know, Shona K does a cramp the style, you know. Sure. No, man, it's even me on the exam, man. All right, let's go. I'm not going to do the natural logarithm one with you just yet, because maybe, no, I'm not going to do that. That's a special rule. So I'm not going to do that one with you just yet. I have 15 minutes. What I'm interested in doing is, Lord, let me go back and check the syllabus. I'm not going to do that one with you. Let me just move to the definite integral. I know the definite integral is definitely there. Let me just highlight. Let me just highlight this. I'm just going to double check that I need to do the.
Are we at the indefinite one?
I'm going to look at the indefinite one, yeah. I'm just going to highlight the natural logarithm one first. I had prepared that one for my calculus 1 class, and I had just dropped it in here.
When you say this at the class now, what time is Saturday class start?
My Saturday class starts at 8 o'clock. But I will send you something. Just chat with me sometime tomorrow in the class, please. Tomorrow. Forgive me.
Sir?
Tomorrow, sometime in the day. Yes, please.
You're going to send the link in the chat?
Yeah. I'm going to put the link in the chat.
Thank you, sir.
Yeah. So as soon as I get the link, Sometimes I get the link Friday night, sometimes I get the link Saturday morning. But yes, I am still extending that invitation for those of you who can make it. And guess what?
Hold on. Saturday night morning, sir?
Sir, trust me, that's what your teacher has to do. 8 o'clock. 8 o'clock, sir, after you get up for go to class. I know what time, sir, finish. Come from our name days? 12 o'clock. From 8 o'clock to 12 o'clock. Yeah, man. But guess what? JD and Yana and Marie and Ophelia, you know, kind of accustomed to them something there. So, all right, let's go.
Get up early past that. I get up early past that, but I'll try.
All right, no problem. All right, let's go. I may not finish this, but I just want to give you the little thing about, you know, oh, that's something along, right? Or so. Yes, Shauna K, you can't miss out nothing right or so now because I want it different. This one are different. Let's go. This one is a definite integral. You have the upper limit and your lower limit. Now, let me explain what is happening here. The upper limit, lower limit. You know, sometimes you we can trouble now. Happy wife, put a little picture and do something the other day, and happy wife I do little construction. Proud of happy wife, you know, things are going on for happy wife, man. But guess what? When that construction is going on, the quantity surveyors may say to her that, you know, you cannot do the construction as it is just now because it's a very rocky type of soil and we have to prepare the place first before we can put on the foundation because it's pure rock down there. So, and he said, geez, is serious? And I said, yeah, man. And she said, we may have to do, and him said, boy, you know, we may have to go blast it, you know, because we now talk about like a baby rock or some big boulders them down there. So, and she said, what for now? I said, well, you know, it's about 250,000 I have to do the blasting because I forgot borrow that time, I forgot borrow this, I forgot rent this and rent that, and 150,000 that time for labor, we got charge $100,000. She said, oh, that put on the price for the something. She said, all right, do it. And then now, when she do the something, she recognized now, say, it gone all the way down, and she can, instead of, she was only looking at a one-story construction. But based on what happened now, she can get 2 stories out of it. And then the engineer says, miss, you know what you can do? You can get a bigger property, you know, and have a basement where you do all of the parking and everything done in the basement. And I'm going to say to you guys, this is where the mathematics comes in play, you know. A lot of you are just doing the mathematics because you want to do it and pass a course. That should not happen. You need to see how the math applies to real world life. So where I live, in a little shack, every other shacks around me, when them lick down the people them house, is an apartment goes up. So it's apartment. It's an apartment city where I live. You understand? Now you know what happens? The man them get a lot, you know. And think about the lot that you may live in. He said, but sir, my lot can't build in the apartment because my lot is small. That's what you thought. Because what the man them doing is digging all the way down, deep down. And what the man them do is put like a 8 or a 10 or a 12 car garage in the basement. So you may say, but sir, 12 cars can't park in the lot when we have, all when the house lit down, they can't park there. No problem. They are going to put it in the basement of the stuff, right? And then no build on top of that. So what the man they begin to do is not 1 story. They may go up to 3 stories, right? So that one little yard where one family lives in, right about now, you may even get up 6 units or 8 units or 9 units now in that one residence, right? So if you look into Kingston, this is what most of Kingston is. This is what most of Kingston, I keep telling my friends, I had a situation where I was doing some outside gardening and a gentleman walked past and engaged me in a conversation to say, are you selling? I said, selling what? Oh, I can offer you X amount of money for the property. And I'm saying, it sounds nice, but why would you? Oh, because he's a developer and he wants to X, Y, Z. So I'm saying this to say to you that a lot of these developers are going into areas that they're enticing people to say, well, I hear the plan. The house I want to fix, you know, so the value of this house, and I know somebody in here is a realtor or work at a property management system, what the people then do is they will come and say, you know, I'm a realtor or a developer, and looking at this house, it really value $10 million. That's the most you can get for this, right? But because I'm interested, I can give you $12 million, right? And the person may say, $12 million, Glovo. All right, can you, what? Okay, let us get into an argument. If I give you this for $12 million, when the place builds, you can give me one of the units, and the development say, of course, we can get a 1-bedroom out of it, and then you still get $12 million. And that's the sort of bargaining now that is going on in the Jamaican real estate market, right? And I know my friend in class,
factual.
Jesus, Father, you know, say, me just about to say, my friend in the class, they come back and tell me, say, sir, it's true. No, this is what I'm saying to you, know, guys. When I come to class to teach, thank you, JG, for agreeing with me. So when I come to class to teach, don't think I come chat with me, no. It is researched information, and I'm trying to put what it is that, how the mathematics relates to real life situation. So the man, they may say to you, you know, sell me give you $12 million. But guess what? Never give you a basement unit for what? Because when them give a basement unit, them not losing, because guess what? When them build a house, they know, them buy your house for $12 million, and we give you one unit or it, you know. But when that unit is being sold, one unit has a class $20 million, you know. So think of him having, or she, whichever developer, is putting on 9 units, and millions of dollars they might get from that. So they can afford to give you that, and them still win. It's a win-win situation, because remember, you know, they never have no plot of land in the first place. So they are winning, and you are also winning, right? So, sir, so how does this relate to the integration? Thank you for asking. You see this upper limit and this lower limit, it tells you the boundary of this plot of land that you're working with. It tells you the boundary of the plot of land. And this boundary of the plot of land can tell you, this is how deep I can go and how shallow I can go. All of you know where to find Excelsior Community College. When you reach Stanton Terrace, the intersection between Stanton Terrace and Mountain View, right across there, coming from Stanton Terrace, to go make the right turn to go down a stadium and reach Excelsior. Right across there, we had a big old-time house called Parity House. They used to do evaluation for London House and Kiara and have other little offices, right? One night, me teach night class. I passed the house and everything was there. And in the following morning, when me passed, I see Oliver tractor. I say, well, go on right here, sir. He said, by the afternoon me come, the building gone. And based on what I drive, I can drive and I can see what is happening over there. Now I'm going to tell you something. They didn't just do that, you know, guys. They dug deep down and went into a basement unit. And I am only assuming, I may be wrong, that it could be a commercial unit, or it could very well be a residential unit, right? I don't know what it is just yet. Now them kind of then zinc it up, so I can't see what is happening, and construction is still going on, right? So it could either be residential or it could be commercial. Commercial rate is that you can have whole heap of cars going under the basement to park. Most of these complexes now in Kingston, there's one on Arden Road where they have a lot of professional places there. They have a monstrosity of parking down at the basement. New Kingston Shopping Center.
Yes, sir.
Basement.
On Eastwood Park Road too.
Yes.
With the new plaza on the left-hand side.
JD, I was driving about 2 days ago and got caught at the traffic, the stoplight right beside the transportation center in Burger King.
Yes.
And I look to my left.
Yes, I see it.
Mister, where this come from? It look nice, you know?
Yes.
Mister, where this come from?
It is discreet, you know, sir. You can't hardly see
it. You can hardly see. I never knew that all of this was taking place there underground basement, because the plot of land is small. So they are integrating right here, so the upper limit, the lower limit, to find the total area. So in a question like this, let me see if sir, you see, I have units squared. Unit squares mean that you're actually calculating the area of the plot of land. Now, when the developer comes and the developer calculates the area of the plot of land, the developer can say, oh, the area of the plot of land, Mr. Shandy, is 74 thirds. And I said, okay, what can I get out of 74 thirds? And so, okay, I'd have to go back to the office and I have to go do a plan to see what can happen. And then now the developer is going to say, this is the square footage that I have for the plot of land. What is a possible thing that I can do? Taking into consideration, the boundary part where him can go because I'm going to be infringing on that and so forth. He can then say to me, the maximum I can get is coming 3 feet from here, 5 feet from there, so forth and so on, from the roadside, XYZ. You can get a 2-story or a 3-story building because of the earth and everything. And he's going to advise me. And this is where you have these consultants in place that come into play, right? Because you pay good money when you go to them, right? These management units where you go and you do the stuff, right? Construction management units. So they will go and do the calculations and they can say to you that this is the best that we can get from it, right? And then but you see, you have to make sure now that when you calculate your area, that all of what it is that you would have done right here would be correct and will therefore give you the correct results. So what we will do next class, all being well, the truth of the matter is, you are now a step ahead of the students that I will be meeting on Saturday, all being well, because what I just spoke to you about is what I'm going to be speaking to them about. So if you want to hear it a second time, I invite you to come out. If not, I will repeat this on Tuesday next week, all being well. What I'm going to ask you to do for me, guys.
Yes, sir. Repeat it on Tuesday.
Yeah, no problem. What I'm going to ask you to do, guys, is I can't send you this document just yet because I want to color code this, but I will send it off to you. I need to double check this piece.
Oh, so sorry. You said you wanted to adjust the first question to put in the C's.
And adjust the first. Thank you very much. And I want to adjust this question number 2 here to put in the C's in order to get the subtotal. So I'm going to work on that. But in essence, though, I have completed now the indefinite integrals. You will see that the definite integrals, and I'm doing this in another minute. I still have a minute to go. When I look at the definite integrals, my integration is the same thing. Let's just do the integration quickly. This is x cubed. It's going to be, this is x squared. It's going to be x cubed over 3. See here? X cubed over 3. This is 3x, 3 to the first, 3x squared over 2. See here? 3x squared over 2. And this is 2, serving an integrator constant. So we get 2x. See here? 2x. So the integration that I just taught you, or I taught you from last class, is the same integration that you're doing right here. The only difference now is to incorporate the units, the upper limit and the lower limit, and that's what we'll continue with next class. Thank you for coming out. Have yourselves a wonderful day.
Give us the time period for the exam.
Right.
Let me have that conversation with you. I don't want to keep it for the other class. Let me have that conversation with you over WhatsApp.
Okay.
That's all right? Shana K, depending on...
I'll get the information.
Right. Thank you, honey bunches.
From Twinny.
From Twinny. Can I tell you? I hope you don't get as much trouble as she does. But anyhow, later, guys. Bless up.
Okay, sir.
Easy.
Sir, bye.
Cool. No, but I thought I ended the session. So what does that mean? Hello? Anybody here?
Oh, you can't end it, sir?
Yeah, it's just not ending at all. Let me try it again.